Hello, this is Ms. DB, and today we are going to work on solving equations by multiplying or dividing. This is Chapter 2, Section 2. Our objective is to solve one-step equations in one variable by using multiplication or division. So solving an equation that contains multiplication or division is very similar to what we just did with solving an equation that contains addition or subtraction. Again, we are going to use inverse operations to undo what is happening to the variable, to undo the operations on the variable. So if it has multiplication being done to it, the inverse of that is division. If it has division as the operation, then the opposite or the inverse operation is multiplication. So we have already learned about the addition property of equality. This is a review that you can add the same number to both sides of the equation and the statement will still be true. We also used the subtraction property of equality already, where you can subtract the same number from both sides of an equation and the statement will still be true. Today we are going to work with the multiplication property of equality that says that you can multiply both sides of an equation by the same number and the statement will still be true, such as 6 equals 6. You can multiply both sides by 3 and you will get 18 equals 18, which is still a true statement. Also, the division property of equality, we'll use that today. That says that you can divide both sides of an equation by the same non-zero number and the statement will be true. Note that there's a little extra piece in this one. You cannot divide by 0. If you have dividing by 0, you write undefined, U-N-D-E-F-I-N-E-D, undefined. But if it's not 0, you can divide by any other number on both sides and you'll still have a true statement. All right, let's look at our first type of problems, which is going to be the variable being divided by some number. So we will undo that by multiplying. So here we have negative 8 equals j divided by 3. That's how we would read that. The variable is j. Right now it's being divided by 3. So we think to ourselves, what is the opposite of dividing by 3? And the opposite of dividing by 3 is multiplying by 3. Now there's different ways to show your work when you multiply both sides by 3. You can put everything in parentheses like they did. They multiplied both sides by 3. They put the 3 in the front and the 3 in the front. If I was doing this problem by hand on a piece of paper and I had j divided by 3, I would just write multiply by 3, multiply by 3. There's more room after the j over 3, so I'd put it at the back. You can also write, let's say, let me do it over here so I don't get it printed on top. You could also put a times sign, like a dot, or on the keyboard that asterisk on each side. Don't lose the negative there, that's part of the 8, negative 8. Or the parentheses, of course, as well. And then on the left side, we have 3 times negative 8. 3 times negative 8 is negative 24. Now look what happens on the right side. Some people think that we have to write 3j over 3 or even 3j. This and this cancel. The 3 that's being multiplied cancels with the 3 that's in the denominator. If you want, you could put this over 1. You don't have to do that. But to make it easier to see that we have a numerator that's 3 and a denominator that's 3, these cancel. So we're just left with j on the right side, which is what we wanted. We wanted to solve for the variable. So now we know that j is equal to negative 24. To check our work, we would just put the negative 24 back in where the j is and see if we get negative 8. Negative 4 divided by 3. Yep, that's negative 8, so it does check. All right, let's look at another example. This one has a decimal in it. We are going to find the variable. The variable is n. And then we say to ourselves, what's happening to the n? What's keeping it from being by itself? It's being divided by 6. That's what this line means. It's a division bar. So we have n divided by 6. We would not usually write that like this in algebra, but you could. You might see it written like that. But usually you'll see it looks like a fraction, but this is a division bar. So n divided by 6 equals 2.8. The opposite of dividing by 6 is, of course, multiplying by 6. So we're going to multiply both sides by 6. And again, if I was doing this, I would just multiply. I'd put the 6 here, and I'd put the 6 here. You don't necessarily have to put the 6 on this side of it. That's because multiplication is commutative. You can multiply in any order. And then I would cancel the 6's on the left side because 6 over 6 cancels. It's the same as 1, so we don't need it. And this would be n equals, and then you get your calculator out that you went to Target or Walmart or wherever to buy, and 2.8 times 6 is equal to 16.8. So we have our value of n, and then you check it by putting that back in up here and taking 16.8, and you probably have that open on your calculator, and you just divide that by 6, and it is indeed 2.8. Here are the problems on your worksheet. Now, I put them on twice. It says if you have trouble reading the problems, if you have trouble reading these problems, I pasted the images in here. I took a screenshot of them and put them here. I did that because I made 1 through 6, these 1 through 6 down here. I made these using the equation editor in Word, and sometimes when you open it on your computer, if you're using an older version of Word than I have, these might show up as like boxes or something. So if for some reason you can't read them, then look up here at this image. That doesn't mean do both of them because they're the exact same problems. So, all right, so number 1, k divided by 4 equals 8. So the variable is k, and you think to yourself, I have k and it's being divided by 4. What is the opposite of dividing by 4? And the answer, of course, is multiplying by 4. So you'll multiply both sides of the equation by 4, and then you'll cancel it on the left side, and you'll get your answer. Let's do number 3. Okay, so number 3, the variable is w. What's happening to w? W is being divided by -7. The opposite of dividing by -7 is multiplying by -7. Don't forget to multiply by the -7. If you don't, your answer will be wrong. So I'm going to multiply both sides by -7. On the left side, we have -7 times -2. A negative times a negative is positive, and 7 times 2 is 14. So I get positive 14 is equal to, now let's see what we have on the right. The -7 cancels with the -7, and I'm just left with the w. So my answer is 14. And then we'll check that by, I kind of messed up my original, but it was -2. Oh, here, I can look up here. It was -2 equals w, but w is 14, over -7. So is -2 equal to 14 divided by -7? Well, 14 divided by -7 is -2. So this checks, it's right, and I can move on. So each of these problems will be solved by multiplying both sides by what the variable is being divided by. So in number 5, g is being divided by 1.9, so you need to multiply both sides by 1.9. And then this will cancel, and you'll get g equals, and then you find out what 10 times 1.9 is. So remember, it's a little bit trickier to show your work on these kind of problems because you're just multiplying both sides by the same number, but try to put it in there somewhere. You could also, since you'll probably be typing your work, you could write this. A times sign 6 times sign, oh, cancel that. I don't know why I would multiply both sides by 6. That would be wrong. Where's my eraser? Because that would not, here we go. That would give you the wrong answer. So remember that first you have to find the variable, which is t, and then say what is happening to the t. The t is being divided by -5. So the opposite of that is multiplying by -5. So you could write this as well to show your work. And then you would do the work. 6 times -5 is -30 equals t. All right. It doesn't look as nice that way, though. All right. Solving equations by using division. Now, You probably have seen a lot of these equations before, but let's look at how you would solve them correctly. We have 9 times y equals 108. So the variable is y. It's being multiplied by 9. So the opposite of multiplying by 9 is dividing by 9. So we will divide both sides by 9. Now they kind of wrote it twice. If I was doing this problem, if I was doing it on paper, I would just put the divide by 9, the 9's cancel, and you get y equals 12. That's how I would show my work. If you're doing it by typing, and you had the problem 9y equals 108, you can type the division bar, which is with the question mark by the shift key, 9, and then division bar 9. Because otherwise you'd have to retype everything. And then you'd get y equals 12. And then we check our work by putting 12 back in for y in your original equation, and then multiplying 9 times 12, because that's what 9y means, is 9 multiplied by y. And 9 times 12 is indeed 108, so we got the right answer. In this example, we have the variable is v, and v is being multiplied by -6. So the opposite of multiplying by -6 is to divide by -6. So make sure you divide by the negative, otherwise you'll get the wrong answer. So -4.8 divided by -6 is positive 0.8, 0.8. Check that on your calculator. And then you check it by putting it back into your equation and making sure that you get the same answer on both sides of your equation. Here's the problems from your worksheet. Let's look at number 8. On number 8, we have the variable is m, and it's being multiplied by -7. So the opposite of multiplying by -7 is to divide by -7. -7 divided by -7, that's 1, so that cancels, and we just write the m. On the right side, we have -28 divided by -7. A negative divided by negative is positive. So our answer is positive 4. And then we check it by just putting it back in. Well, I'll put the 4 here. And seeing if this is indeed equal to -28. And it is, so it works. All right, so there's one more type of problem I want to look at. It's when you have a fraction. So dividing is actually the same as multiplying by the reciprocal. So sometimes you're going to find it easier to multiply by a reciprocal rather than dividing, especially when we have fractions. For example, here we have the variable w is being multiplied by 5/6. Now we could divide both sides by 5/6. That's legitimate. But that's a little bit time consuming, and when you divide by a fraction, the rule is to multiply by the reciprocal. So instead of taking this extra time to divide by the fraction, what we're going to do is multiply both sides by the reciprocal right away. So here's what happens when you do that. The left side, we have 6/5 times 5/6. The 6/6 is equal to 1, so that cancels. The 5/5 is equal to 1, so that cancels. And all you're left with is w. So multiplying a fraction by its reciprocal is the same as getting 1 or canceling it. And then you just have the variable. On the other side, I put a 1 under the 20 to make it look more like a fraction. Let's look at this over to the side for a minute. On this fraction, you could go ahead and multiply straight across numerator, straight across denominator. You'd have -20 times 6 is -120. 1 times 5 is 5. And then you could use your calculator if you're not sure what to do next, and 120, or you can do long division. 120 divided by 5 is 24, and there was a negative, so this would be -24. This is an easier way to do it, is to cancel before multiplying. So we have a 20 in the numerator and a 5 in the denominator. the factors of negative 20, or let's just say 20 for now, is 4 times 5. And 5 is also in the denominator. That means that, and of course 5 is a factor of 5. So I can think to myself, 5 divided by 5 is 1. 20, or negative 20, divided by 5 would be negative 4. So I'm simplifying, I'm canceling before multiplying. And then on the denominators, you just have 1 times 1. You don't have to write that. In the numerators, you have negative 4 times 6 is negative 24. So either way, we're going to get negative 24 for our answer. All right, here's all the steps written out with the, I'll erase my marks here. So they multiplied both sides by 6/5, just as we did. And they got W equals negative 24 a little quicker and magically. And then they're checking their answer, 5/6 times negative 24. Now, this might be a little tricky as well if you're not used to working with fractions. To check, you can either go 5 times negative 24, and then on the bottom you'd have 6 times 1. Or you can do the canceling again. You can say, well, 6 goes into 6 one time, 6 goes into negative 24 negative 4 times. And then on the denominators, we just have 1. And on the top, the numerators, we have 5 times negative 4 is negative 20. So we do get the correct answer. Here's another one with fractions. Let's look at this one. We have 3/16 equals 1/8 z. There's fraction on both sides of this one. So which one do you have to multiply by the reciprocal? Well, remember that we are only really concerned about the variable and what's happening to it. It is being multiplied by 1/8. The opposite of multiplying by 1/8, we could divide by 1/8, or we can multiply by its reciprocal, because that's the same as dividing by a fraction. So we're going to multiply both sides by 8/1. Now on the left side, when you multiply 1/8 times 8/1, this all cancels and you're going to be left with just the z. On the other side, on the left side, let's cancel first. Before we could write this as 24/16 and then simplify, but let's practice our canceling skills. So we know that 8 goes into 8 one time, and 8 goes into 16 two times. 16 divided by 8 is 2, 8 divided by 8 is 1. So we're left with 1 times 3 is 3, and on the denominator 1 times 2 is 2. So our answer is 3/2, or if you want, you can change it to 1 and 1/2 or 1.5. So their steps are going to look similar, except a little bit different. The way they show their multiplication looks a little bit different. And they multiplied by 8 instead of 8/1. 8 and 8/1 are the same thing. And then we check it by plugging in our answer of 3/2. This is a little bit trickier to check as well. We're going to have to multiply these fractions and see if we get 3/16. I guess this isn't tricky. When you multiply fractions, you just multiply the two numbers on top, and then you multiply the two numbers on the bottom. So we get 3/16 equals 3/16, so it checks and it's all good. One more example. Since these are a little bit trickier, why don't you pause the video, try this one, and see if you get the right answer. All right, so did you say that the reciprocal of 1/6 is 6? And really, this one, we don't even have to deal with fractions, because we multiply both sides by 6. We just have two whole numbers. 6 times 102 is 712. And then if you take 1/6 times 712, that's the same as 712 divided by 6. So you could take 712 divided by 6, and you will get 102, and you'll get the right answer. These are the problems from your worksheet. Let's look at number 14 to start with. And number 14, we have 6 equals negative 3/5 times x. So I'm going to multiply by the reciprocal of negative 3/5. And the reciprocal of negative 3/5 is negative 5/3. Now, I don't really have a lot of room on the other side. Whoops. I was trying to find like a box. What do I got here that I could use? Not much. I was going to try to erase my 14 and make some more space here. Let me just do it over here. 6 equals negative 3/5 x. That's my problem. And I'm going to multiply both sides by the reciprocal, which is negative 5/3. Now, if it bothers you that the x is here and in between these two, you can put the x at the end. And then I'm going to multiply this side by negative 5/3 as well. So the easiest side on this one is the right side, because what you're multiplying by, when you multiply by the reciprocal, you just get 1. The 5's cancel, the 3's cancel, a negative times negative is positive, you're just left with x. Now on the left side, I'm going to put a 1 under the 6. So I have negative 5/3 times 6 over 1. That's what I'm multiplying. Is there anything we can cancel to make this a simpler problem? Yes, because the 3 and the 6. 3 is a factor of 6. So I can go 3 divided by 3 is 1. 6 divided by 3 is 2. So now I have negative 5 times 2 is negative 10. In the denominator, I have 1 times 1. That's just 1. You don't have to write a denominator of 1. So my answer is negative 10. Now to check your work, we put it back into the original. So I would have 6, I want to see is 6 equal to negative 3/5 times 10. To do the multiplication on the right side to see if it's equal to 6, I'm going to put a 1 under the 10 so that I have two fractions, and then I'm going to look for something I can cancel. 5 is a factor of 10. So I can take 5 divided by 5 is 1, 10 divided by 5 is 2, and negative 3 times 2 is negative 6. Where did I lose my negative? Oh, right here. I forgot to put a negative 10 in for my answer. Negative 3 times negative 2 is a positive 6. So if I would have ended up with, on my check, 6 equals negative 6, I would have to go back and find my mistake. My mistake was in the check. The answer is negative 10, but I had written a positive 10 there instead. So the answer is negative 10. Let's also look at number 16. I'll start number 16. This says that 1/2 a is equal to 17. The reciprocal of 1/2 is 2, or 2 over 1. So if I want to undo multiplying by 1/2, I could divide by 1/2, or I can just multiply both sides by the reciprocal of 1/2, which is 2. I'm not going to put 2 over 1. It's just 2. And then the 2's cancel, and I'm left with a equals, and then you can find out what 17 times 2 is. That one ends up being simpler. Okay, so here's the real test of your work. This is mixed problems, including problems from section 1 and section 2. So you have to decide, do I add, subtract, multiply, or divide to solve this? Remember to show your steps and to check your work. You don't have to show the check on these problems on your worksheet. You can check them on your own paper and don't have to submit that part. So let's see. In number 17, we have 3 times x. So your first step would be to divide both sides to undo the 3. In number 18, we have x is our variable. All of these are variables are x. And I'm adding 39. So the opposite of adding 39 would be to subtract 39. Notice that this is negative 181 minus 39. So make sure that you solve this correctly, remembering that if you have, if they're both negative, you're going to have, let me write this as adding the opposite. This is the same as negative 181 plus negative 39. So the rule is when they're the same sign and you're adding, you add them together and then take the sign of both. In number 19, we have x minus 12, and the opposite of that, of course, is to add 12. So again, be careful with your negatives. You have negative 20 plus 12, and see what you get. And let's look at 21. Now 21, I typed rather than using the equation editor kind of thing. So it doesn't necessarily look exactly the same as the other ones, but this means x divided by 8. And the opposite of dividing by 8, I could have wrote it this way. The opposite of dividing by 8 is multiplying by 8. So we will get x equals, and then you can figure out what that is. In 22, this is one where we are multiplying by a fraction. So the easiest way to undo that is to multiply both sides by the reciprocal of that fraction. So I'm multiplying both sides by 4/3. And then the left side, this will cancel, and you'll get x equals, and then you'll have to do the right side and make sure that you see that this is a negative 15/1 times 4/3 and find out what you get. All right, I'll let you finish those up. And there's one more. This is an application problem similar to the one that's in your textbook. Ciro puts 1/4 of the money he earns from mowing lawns into a college education fund. This year he will add $285 to his fund. That's not a lot of money. Write and solve an equation to find out how much he will earn, or how much he did earn mowing lawns this year if he put 1/4 of the total into his college fund and it equaled $285. So 1/4 of his earnings equals $285. They wrote that as m/4, but you could just multiply both sides by the reciprocal, which is 4 as well. You could have left it as 1/4 times m. And then they got their answer of $1,140 is what he earned. Okay, here's another problem that's on your worksheet, an application problem, a geometry application problem. It says that two segments are congruent, so their lengths are equal. That's what it means if you have congruent segments. One segment, AB, is labeled 14 inches, and the other segment, CD, is marked 6x. Write an equation to show that their lengths are equal and solve for x. So you're going to say that this one is equal to this one. It doesn't matter if you write 14 equals 6x or 6x equals 14, and then you solve, and you'll get a decimal for your answer. I'm not sure what it is, but... All right, that's all for today. Thank you very much, and be sure to let me know if you have any questions at any time.